This lecture is about how to write formulas for ionic compounds. In class, we're going to be working with chemical nomenclature, which are the rules that are used to write names for chemical compounds, and you need to be able to do both. You need to be able to write formulas and name them. So this lecture is going to cover a couple of approaches for writing formulas for ionic compounds, and you'll learn about the one that I really would like you to use, but I'm going to show you a couple. So we're going to cover the basic information and then jump right into how to do it. So you're going to see some review of some terms that we've been using for a while when we talk about writing formulas. First term that we need to review is what an ion is. An ion is an atom or a group of atoms that are bonded together that have a positive or negative charge. And they have a positive or a negative charge because electrons have been gained or lost. There's two different kinds of ions. The first kind, remember, is a cation. Cations are an individual atom or a group of atoms that are bonded together that is carrying a net positive charge. And then anions are atoms or group of atoms that have a net negative charge. Now, we covered these terms when we were talking about chemical bonding, but definitely need to review them. Ions come together to form compounds. Now, we know that there's a couple of different kinds of chemical compounds. Specifically, we're learning about how to write formulas for when ions come together, so for ionic compounds. Chemical compounds are substances that contain two or more different, and it's important that you note that the elements are different, that are combined in a fixed proportion. Basically, that means that you have a certain combination of them, and there's only one particular way that you can form that particular compound with those particular elements. And they are held together with some kind of chemical bond, be it an ionic bond or a covalent bond. Okay, and again, I want you to pay close attention because we're focusing on just ionic here. You're going to be learning how to write, how to name compounds with ionic bonds and compounds with covalent bonds in class, but I'm only ever going to have you write formulas for compounds with ionic bonds, at least following these particular rules that we're learning here. Now, we're going to get a little more specific about cations and anions. Cations, when we're talking about ionic compounds, the cation will either be a metal or the polyatomic ion ammonium. And remember, you should have committed to memory the chemical formula for ammonium, which is NH4 plus 1. Our anions will be nonmetals or any one of those other polyatomic ions. And if there's ions that I want you to know about, or I should say polyatomic ions that I want you to know about that weren't on that list, I would give you the formula for the ion and its charge. Okay. Now, to form an ionic compound, two ions have to come together. So, you got to remember this really important idea that, again, and I have told you this multiple times this year, that we're going to keep using this idea that unlike charges attract, like charges repel. Okay, so you got to kind of try to keep that idea in mind as you're working with this stuff. So there's times when two ions come together that they're not going to form a compound. For example, when you have a positively charged cation coming together with another positively charged cation, you're not going to get anything, no compound. Now, two anions, so two nonmetals, can come together, but they're not going to make an ionic compound. And so I should say will not make an ionic compound. Okay, so that's the review of the basics that we've already talked about. All right, so now we're diving into the new stuff. How exactly do you write a chemical formula for an ionic compound? Well, a couple of things that you need before you can write the formula using either of the approaches that I'm going to show you. The first thing that you need to be able to do is use your periodic table to help you look up charges of the elements that are involved. Now, sometimes this can be tricky because sometimes elements, particularly metals, those transition metals that fall in the middle of the table, so groups 3 through 12, they might have more than one charge for the cation that they form. In that case, I would tell you which one I wanted you to use. Okay, but remember that if you look at the table that I gave you, at the top of every column, I wrote the charge for elements that are within that column. And actually, you can also look at your table and you will see that it's written next to the atomic symbol as well. Okay, so periodic table you can use. And remember, I did have you memorize the formula in charge of a bunch of polyatomic ions, 10 of them, in fact. Okay. Now, there's two options that you can use to get the chemical formula. There's one that's called the crossover rule, and this rule says that the charge on the cation becomes the subscript on the anion, and the charge on the anion becomes the subscript on the cation, and they drop their signs. Okay, you want to make sure that you remember that. The signs drop. Basically, the charges switch what they're paired with, they lose their sign, and they drop down to become subscripts. This is a good procedural approach, but there's some things that you have to remember if you're using the crossover rule. The one that I would prefer you use is this one, the common multiple approach. So there's going to be some steps that you need. So the first thing you're going to do is you're going to record the value and the sign of the ionic charge underneath each element or ion in the compound. You need to recognize that the charge of a compound is always 0. So you got to keep that in mind. You're going to find the common multiple of the two charges. So say, for example, you have a metal with a +2 charge and a nonmetal with a -3 charge. Their common multiple is 6. Okay, so you have to have 6 positive charges and 6 negative charges to cancel out to add up to 0. Okay, so you'll figure out how many of each atom you need to get the sum to 0 by dividing the common multiple value by the ionic charge. And the answers you get will tell you the number of that ion you need in the formula. Okay, this is the approach that I will be using, but I will, for some of you who need to see or want to see another approach, I will show the crossover rule in class in smaller groups. Couple of things that you do need to keep in mind when you're writing a formula. First of all, formulas are always written the metal, then the nonmetal or the cation, and then the anion. So for example, that's why we write sodium chloride NaCl, metal, nonmetal. Okay, that's the convention, that's the rule. The other thing is that compounds have no charge, so the ions have to add up to 0. Okay, so the charges have to cancel each other out. So we're going to look at some examples and then see even more examples. So I'm going to show you how to use both approaches on this slide, and I'm going to show you for the same pair of ions. So this one will be for the crossover rule, and this one is for the common multiple. And I'm going to do the common multiple one first, just because. Okay, so say for example, you have to write the chemical formula for when zinc and bromine combine to form a compound. Well, the first thing you need to know is the atomic symbol. Zn is zinc, Br is bromine, okay? And you're going to look up the charges. Okay, so next to zinc, you would see a 2. Your table doesn't always necessarily show the signs, but zinc is a +2. And next to bromine, you would probably see a minus sign, or it might say -1. Okay, so there's step 1. Okay, so we looked up the ionic charges. Step 2 is remember that the charges have to sum to 0. Okay, so their common multiple is 2. So we'll work with the zinc first. Okay, so we'll work with the zinc first. So the first thing that you want to do is the common multiple. You write that down first. So the common multiple is 2. Okay, and you divide it by the charge, the ionic charge, which for zinc is +2, and you get a 1. Okay, we're going to do the same thing for the bromine. The common multiple is 2. Okay, and you divide it by the ionic charge. -1, 2 divided by -1 is 2. Okay, so this number right here tells you that you need 1 zinc, and this number right here tells you that you need 2 bromines. Okay, so the chemical formula ends up being Zn. Now you don't have to write the 1 because just the atomic symbol implies 1. And the atomic symbol next to bromine, we do have to put a subscript of 2 there. Okay, so that is the common multiple approach. And the common multiple approach is really the one I would like you to be using. But we'll go over and we'll look at the crossover rule. Okay, so same compound, zinc and bromine. Okay. Now, the crossover rule is much more procedural. It doesn't really show how well you understand that charges have to sum to 0, and there's some tricky things with the crossover rule that pop up that don't pop up with the using the common multiple approach. But again, you start with your periodic table. Okay, so you're going to look up the charges. Okay, so we've got zinc. So the atomic symbol, zinc is a +2. We look up bromine, and we see again bromine is -1. Okay. Now, what the crossover rule says is this -1 comes over here, this +2 comes over here. They drop their signs, so they swap, they drop, and they become subscripts. Okay, so in other words, you end up with Zn. Again, we don't have to write the 1. And this time I put the line through the zinc just so you knew it was a zinc. And the Br, you do have to write the 2. But they don't have the signs anymore. Okay. So on the next slide, we're going to go through and do a whole bunch of examples. And because the common multiple approach is the one that I'm going to want you to use, or I should say I don't want you to use it, but it's the one I prefer you use, that's going to be the one that I use as I'm going through the examples. So we got a whole bunch of them here, okay? So I set these up so that you had the atomic symbol already, okay? But again, this first one, strontium and chlorine, so it's Sr +2. Okay, make sure that that does look like a plus. There we go. And Cl -1. Okay, this is very similar to the example that we just did, unfortunately. Okay, so you start here. The common multiple is 2. Okay, so you take the common multiple that goes in your numerator, so it's 2. Oops. Okay, and you divide it by the charge, which is +2. Now I just did that first, and so that gives me a 1. Okay, then I do the same thing. Take the common multiple, divide it by the ionic charge, and that gives me a 2. So I have Sr. I don't have to write the 1. I do have to write the 2. Okay. The next one, Mg and S. Okay, well, Mg is, when you look up magnesium, you see that it's +2. Okay. S is -2. Okay, so there's the charges. So you're going to take the common multiple again. In this case, is 2. Okay, so you are going to, so common multiple is 2. Okay, so you take the common multiple, you divide it by the ionic charge, And for the magnesium, you see that you need 1 magnesium in the compound. Okay. And then you do the same thing for the sulfur. You take the common multiple. So the common multiple, which is 2, and for some reason it keeps cutting parts of my 2's off, and you divide by the ionic charge, and you get 1. Okay. So the chemical formula here, Mg, S. You don't have to fill in the 1's. Okay. This compounds that are like this one, where the charges on the ions are equal but opposite, using the common multiple approach gives you it leaves you with the chemical formula in the correct form. Sometimes if you were to use the crossover rule, you would end up with multiples of what the compound should be set up, and you'd have to do some reducing. Okay, so that's one of the reasons why I would prefer that you use the common multiple approach. Okay. All right, this next compound, we've got one of the polyatomic ions that you were supposed to know tossed in here. Not any different. Okay, so aluminum is +3, and this ion, SO4, is -2. Okay, so the common multiple here is 6. Okay, so we've got to do a little bit of work to do here. So again, you take the multiple. We'll work with the aluminum first. 6 divided by +3 gives you 2. Okay, so that's 2 aluminums. Okay, you do the same thing for the sulfate. You take the common multiple, 6, divide it by the ionic charge. So 6 divided by -2 is 3. So you need 3 sulfates. So the way you would write this formula is Al2. Put the SO4 in parentheses because you want to show that that 3 applies to each one of them. Next one, you've got potassium and oxygen. So I'm going to stop explaining quite so much. I'll go through this one, but then for the rest of them, I'm going to want you to try them on your own, and I will fill in the answer so that you can see how they look. But the next one, K plus 1 and O minus 2. So our multiple is 2. Okay. So you take the multiple, divide it by the ionic charge. So, okay, so for the potassium you get 2. You take the common multiple, divide it by the ionic charge. Okay, and you get the number of oxygens in the compound. So this chemical formula is written K2O. All right, so I'm not going to go through the steps quite so much. Calcium and phosphorus, Ca plus 2, P minus 3. The multiple is 6. So 6. Okay, so we need 3 calciums, and 6 divided by -3 is 2. So this chemical formula is Ca3P2. Got another polyatomic tossed in here, strontium and nitrate. Strontium is +2. Nitrate is -1, so the multiple is 2. So 2 divided by +2 is 1, and 2 divided by -1 is 2. So this formula is SrNO3-2. Got another polyatomic in this one. It's ammonium, NH4, and I tend to put them in parentheses so that you can see that the charge applies to the whole deal. So you got ammonium and you've got sulfur. So again, the common multiple is 2. So you take that, you divide it by the ionic charge. So for the case of ammonium, 2 divided by +1 is 2. And 2 divided by -2 is 1. So this is NH4, again in parentheses with the 2 on the outside, NH42F. The next one, you have calcium, which is Ca plus 2, and carbonate, CO3 minus 2. The multiple is 2. So you take 2 divided by plus 2 is 1. 2 divided by negative 2 is 1. Okay, so you end up with CaCO3. Now, I don't put the parentheses around the carbonate because there's only one of them. You can put parentheses around it, but the convention is to not have them there. All right, this last one. So here's why you have to remember the charges on the polyatomic ions. We have NH4 plus 1, PO4 minus 3. The multiple is 3. So 3 divided by plus 1 is 3. And 3 divided by negative 3 is 1. So this is written, and hopefully I have enough space here, NH43, PO4. So when you get to class, next time you should be prepared, or when we first come in, be prepared to do some practice with this. And I will be able to touch base with you in smaller groups to go over questions that you might have. So what a good idea would be to do along with these examples right now is write down any questions that you have as you've viewed and listened to this lecture.